Lesson 41, One-Way Analysis of Variance. Example 2. Ecologists monitoring the population of rainbow trout in California caught, examined, and measured some specimens in the Yuba, Sacramento, and Truckee rivers. The weight in ounces of the rainbow trout gathered by the ecologists is presented in the following table by the location where the specimen was caught. So here are their results. Conduct a hypothesis test using alpha equal 0.05 to determine whether the mean weight for the population of rainbow trout in the Yuba, Sacramento, and Truckee rivers are all equal. So in this example, we're going to conduct a hypothesis test using the customary alpha equals 0.05. To determine whether the mean weight for the population of rainbow trout. Thus, this test involves the population parameter mu for the mean weight in the Yuba, Sacramento, and Truckee rivers. Thus, we're dealing with 3 population means, mu1, mu2, and mu3, where the first population refers to the rainbow trout caught in the Yuba River, and the second population refers to the rainbow trout caught in the Sacramento River, and the third population refers to the rainbow trout caught in the Truckee River. So here in this test, we're going to determine whether the mean weight for the population of rainbow trout in the Yuba, Sacramento, and Truckee rivers are all equal. That is, does the mu1 equal mu2 equals mu3? A one-way analysis of variance is used to determine if the means for more than 2 populations are all equal or not. In order to apply a one-way analysis of variance, each of the independent random samples must be selected from populations that reasonably follow a normal distribution with approximately equal variances, or standard deviations. Thus, we'll be conducting our one-way analysis of variance under these assumptions. So, to follow the steps of our one-way analysis of variance hypothesis test procedure, we begin by stating the hypotheses. HO and H1 are always stated in the same manner in a one-way analysis of variance. HO is always that all of the population means are equal, and H1 is always that not all the population means are equal. Now that we've stated the hypotheses HO and H1, we then identify our alpha level of significance. Here we're using the customary alpha of 0.05. Now we can use the TI-84 calculator to calculate the p-value to reach our decision. To do this, we need to enter the sample data into the lists. So here are the sample results of the weight of the rainbow trout caught in the first sample, the Yuba River, the second sample, the Sacramento River, and the third sample, the Truckee River. These sample values can be entered into the TI-84 calculator by pressing Stat and Enter to enter the list editor. And then we need to arrow up and press Clear Enter to clear out lists of old data to make room for the new data. Now the first sample, the weight of the rainbow trout caught in the Yuba River, is entered into the first list. 38.4, 16.7, 62.0, 45.1, 37.2, 39.5, 53.4, and 38.9. Now in the second list, we'll enter our second sample, the weight of the rainbow trout in the Sacramento River. 60.5, 71.7, 46.2, 77.4, 49.1, 56.3, 67.9, and finally 63.1 ounces. Now in list 3, we'll enter the weight of the rainbow trout caught in the Truckee River. 39.6, 56.3, 38.5, 32.1, 54.4, 42.8, 40.7, 19.3. Now that we've entered our 3 samples of data into our 3 lists, we can continue with our hypothesis test procedure. To calculate the p-value for this test, we need to execute the ANOVA command. To get to the ANOVA command on the TID4 calculator, we press Stat, arrow over to Tests, and then an arrow up so the cursor is next to ANOVA. Press Enter to select, and then enter in the lists of data, starting with second 1 for list 1, comma, second 2 for list 2, comma, second 3 for list 3. Close parenthesis, enter, calculates the p-value for our test. And rounding the p-value to 3 places after the decimal, we see that the p-value is approximately 0.003. Now that we have our p-value, we can reach our decision. Since the p-value of 0.003 is 0.05 or less, the decision is to reject HO. And when we reject HO, we have sample evidence indicating that HO is not valid, and hence H1 is valid. Thus, our conclusion here would be that not all of the population means are equal. So, based on the results of our hypothesis test procedure, we can make the following statement. Therefore, the mean weight for the population of rainbow trout in the Yuba, Sacramento, and Truckee rivers are not all equal. The results of this hypothesis testing procedure only leads to the conclusion that the means for these 3 populations are not all equal. It does not indicate which of the particular means are not equal or specifically how they differ. In order to determine which particular population means are not equal and specifically how they differ, all pairwise comparison confidence intervals could be constructed to estimate the actual differences in the population means with a 1 minus alpha times 100% simultaneous level of confidence. The 3 population means require 3 pairwise comparison confidence intervals. One to compare the difference between mu1 and mu2, a second one to compare the difference between mu1 and mu3, and the third one to compare the difference between mu2 and mu3. In this case, these would be comparing the difference in the mean weight of the trout caught in the Yuba and the Sacramento rivers, the Yuba and the Truckee rivers, and the Sacramento and the Truckee rivers. For the 3 pairwise comparison confidence intervals to achieve a 1 minus alpha times 100% level of confidence simultaneously, each individual confidence interval estimate must be constructed with a cube root of 1 minus alpha level of confidence. Use the data gathered by the ecologist to construct all pairwise comparison confidence intervals to estimate the difference in the mean weight for the population of rainbow trout in the Yuba, Sacramento, and Truckee rivers with a simultaneous confidence level of 95%. And interpret the results. So here we're going to use the data gathered to construct all pairwise comparison confidence intervals with a simultaneous confidence level of 95%. For the 3 pairwise comparison confidence intervals to achieve this customary 95% level of confidence simultaneously, each individual confidence interval estimate must be constructed using 1 minus alpha equal to the cube root of 0.95. Also, to estimate the difference in the mean weight for the population of rainbow trout in the Yuba, Sacramento, and Truckee rivers by doing this in pairs, we need to conduct a confidence interval estimate for the pairs of two population means. Thus, the following guides us through the confidence interval estimate for the difference in the pairs of the population means. This involves conducting a 2SAMP-TINT command on the TI-84 calculator. And this command would have to be repeated 3 times to make the estimates for each of the 3 pairwise comparisons: the mu1 minus mu2, the mu1 minus mu3, and the mu2 minus mu3. And after we construct these 3 pairwise comparison confidence intervals, we then need to interpret the results so that we could tell which of the population means differ significantly from the others. So, to conduct a 2SAMP-TINT command on the TI-84 calculator, we would press stat, arrow over to tests, and then arrow down until the cursor gets next to 2SAMP-TINT. And then we press enter to select. Here we have data that was inputted, and for the first pairwise difference between mu1 minus mu2, we need to use the data in list 1 and list 2. For the confidence level, we need to do a cube root of the 0.95, so we press 3, and then math, and arrow down to the root symbol, enter, and then 0.95. Pressing enter will calculate the cube root of 0.95. Pooled is always no, for our case, and then arrow down to calculate, press enter. So here we find the estimate of the difference between mu1 minus mu2 ranges from a negative 36.58 to negative 3.67. Now for the second comparison, we press stat, arrow over to tests, and select 2SAMP-TINT. Here, for the difference between mu1 minus mu3, we need to use the data in list 1 and list 3. Keeping everything else the same, we arrow down to calculate and press enter. And here we find that the difference between mu1 and mu3 ranges from a negative 16.08 to a positive 17.95. Now for the third comparison, mu2 minus mu3, we press stat, arrow over to tests, and then we need to use the data in list 2 and list 3. Arrow down to calculate, press enter. And here we see the difference ranges from a positive 5.73 to a positive 36.39. So now we can use these results to reach a conclusion. When both L and U are negative, the interpretation is that the first mean in the difference is less than the second mean. In this case, the first population were the rainbow trout caught in the Yuba rivers, and the second population was the rainbow trout caught in the Sacramento rivers. So this result indicates to us that the mean weight of the rainbow trout caught in the Yuba River is less than the mean weight of the rainbow trout caught in the Sacramento River. When both L and U are positive, the interpretation is that the first mean in the difference is greater than the second mean. So in this case, mu2, the mean weight of the rainbow trout caught in the Sacramento River, is greater than mu3, the mean weight of the rainbow trout caught in the Truckee River. When L is negative and U is positive, the interpretation is that there is no significant difference between the means. So in this case, ranging from the negative 16.08 to the positive 17.95 indicates that 0 is included in this confidence interval, thus making the difference between mu1 and mu3 not significant. That is, the mean weight of the rainbow trout caught in the Yuba rivers is approximately equal to the mean weight of the rainbow trout caught in the Truckee rivers. Thus, the mean weight for the population of rainbow trout in the Sacramento River is anywhere from 3.67 ounces to 36.58 ounces heavier than those in the Yuba River, and anywhere from 5.73 ounces to 36.39 ounces heavier than those in the Truckee River. Furthermore, there is no significant difference in the mean weight for the population of rainbow trout in the Yuba and Truckee rivers.